So we're talking about CIDR, classless interdomain routing. We mentioned earlier when we talked about initially subnetting, class A, class B, class C, that is class full routing. And we're getting into what is called classless. So breaking up a single domain or single grouping into smaller pieces. So for the sake of sanity, we are only going to be dealing with breaking down class C networks into smaller chunks. We're not worrying about class A, class B at all. We are only focusing on class C, which, let me share my screen here. So class C, so we'll give us a 255.255.0. This in. So class C means these first three groups are our network address, and only this last little group here is for our host, right? So we remember that? Is that a yes? No? All right.
Yes.
All right.
Yes.
This is a workshop. It's more two-way communication on this one. So, we're gonna be talking a lot. All right. So if we're only dealing with this, so say, we were given a class C network, which would be, let's say it's 192.168.20. That is our network, which gives us this last chunk where we would have 0 to 255, right? So we get a total of 256 options, minus the fact that we have to take one away for what's called the host and one away for the broadcast, but we're going to ignore that for right now. So we technically have, a little like 254, let's say, potential hosts we can use, right? So what if I wanted to break this down into a smaller network? And remember how we can notate this. This is also a /24, right? /24. So that lets us know that it is a CIDR subnet. And then just for slightly more confusion, I guess you could say, the binary for this is going to be so this is the binary for our subnet, which basically comes out to this same thing right here. So this right here on the bottom, this and this mean the same thing. So now what we can do, if we know that all the ones equal our network address, so same thing up here, 255.255.255, that is 3 blocks of 8 ones, that equals our network. Same thing down here. We can do what's called a CIDR, break it down into smaller groups and add more to that network. So I could say, I want to take one more bit right here, this one little 0, and I want to make that also part of my network address, right? So as we talked about before, our network address was 192.168.20, right? So we now can take an extra bit after that, which is a portion of this, and make that also the network. So what are our options with a binary bit? What can we do with it? What are the things it can do?
It could be a 1 or a 0.
Correct. So we have two options, right? It's binary. It could be 1 or a 0, on or off, right? So now if we're using this one more bit, we have the option of 0 or 1. So that gives us two more networks. We can go to our ANDing. I'm never going to get that lined up again. So we can go to our ANDing here. So I have everything off, it means 0, right? And if I go down the line, and remember this first bit, this 128 bit right here, this was our network, right? Because that's that first bit into the new CIDR. So this is a 0 for now, which means I can go from 0 up here, or I can turn on all my bits. 1, 2, 3. What just happened? All right. All right, so 0 all the way up to 127, right? That would be our main network. So go back to our nearpod. Yeah, it's still lined up. So this network would be 0 to 127. And if we turn that bit on, you would have 128 to what? Excellent, Rahel. 255. So we now have two networks broken up. 0 to 127 and 128 to 255. Based upon the address I have up here, which one of these two networks would that address be in?
The 128 to 255.
There you go. So as it comes into our network, it sees this and it is able to route it into the network that we have designated, which is the 128 to 255. This is CIDR. So we've added a bit. Instead of one network, we've broken our network out into two, and we're able to create two smaller networks out of one larger one, right?
But how, like,
sorry, I don't get it.
Yeah, if it because the thing is, it's not like it's adding a bit, it's taking away from
It's utilizing this bit as part of the network address rather than the host.
Okay, so but could this address right here couldn't be used as a regular network address? Like,
it wouldn't be routed over the internet, but when it entered into our network, and how we would notate it would be so instead of /24 like you see here, it would be /25. letting it know that that extra bit is to be used as part of the network addressing.
Okay, so that's what would tell, that was my whole question. Like, how would it know to do that? You know, how
Yeah,
would it
so
know to
and
do
then in
that?
our subnet mask, as it's coming across, this 0 would become a 1.
Okay.
And
All
then
right,
they
thank you.
also would change this. This would be 255.255.255.128
Okay.
because of that first bit is 128, right?
Yep.
Okay. So we got this concept down pretty good. Okay, at least.
Yeah, now I do.
Golly.
I'll say no, but I don't want to hold everybody back. So maybe another example, I'll understand it.
Well, yeah, we'll expand upon it a little bit and we'll see if that clears things up.
Okay.
So let's build a little bit upon what we're saying. So instead of using 1 bit, we want to use 2. So this becomes instead of a /25, this now comes what's called a /26, letting it know that we're going to be using the 2 bits for our network addresses, right? So we know with a single bit, what are our options? 0 and 1, right?
Right.
With 2 networks, we have 2 bits. So we can go 0, 0, 0, 1, 1, 0, and 1, 1. So we've now doubled. First we had 2. We've now doubled the amount of networks we have, right? And that's going to cut our computers or hosts we can have in each network by half, because we're not going to be able to have, 0 to 127, right? So we still have to break up this network into smaller chunks. So we'll now go 0, was it the 63? No, 64, excuse me. No, right the first time, 63. And then 64. Man, writing is terrible today. Apologies. 64 to 127. 128 to 192. And then 191. Sorry. 192 to 255. So you see, we've now created 4 networks because we have the 2 bits, we're able to create 4. And then we had to break down our networks into 4 equal portions based upon what we can do in that ANDing chart with these 4 bits.
So you can have up to 4 subnets.
Yeah, you're creating subnets.
So like, okay, so on one network, you can have 4 subnets with, but how many hosts can you have on the subnet?
Well, if you have 4, I believe we can have, was it 62? Because you would have 64 in each subnet, and then you have to remove 1 for the host, which is the host of that network, and then 1 for the broadcast address for each network. So each network is -2.
Okay.
So you would equally divide them and then subtract 2 from your leftover chunks. So does this make sense? Where first I had 2 and I kind of split the hosts in half, put half in one group, half in the next. Then I broke it up into 4 groups. Now I have 4 equal groups creating these ranges with each one. So if I looked at my original IP address, call these A, B, C, and D. Looking at the original IP address I gave you up here, which network would it go in?
E.
C.
C. C. Because the 183 is my host address, right, on that network. And then I would look down at my groupings and see which one this range falls inside.
Okay, so I think the thing maybe I missed was, okay, so even though we're looking at the host, so the host have his own subnets of network.
Yeah. So basically, you're taking this little chunk, which is what the internet provider gives us, this chunk of networks, of host addresses. We, in order to make things more efficient and work better for our company, can break it down into smaller, manageable pieces called subnets and make it more functional for us.
And then and those subnet masks, so you just like kind of just do the class A, B, and C, and D in there?
Well, you would use slash notations. You can use this, but it gets a little trickier with the math. But so where we would initially, we had a /24 with just these three, right? In order to indicate to my router to use the first two bits of that last octet, I would put /26 because I'm using the extra 2 bits rather than the /24.
Okay. Yeah, I'm getting into it.
Okay.
So
This is going to help me understand the network model on week 3 of Coursera.
Yes, that's why we're doing this. Is that what you were saying? This will help you understand how to map that?
Yes, it will. Yes.
Yeah, that particular quiz is exactly what led me to do this workshop the first time I saw it. I'm telling you right now, what we're doing right here is above and beyond anything you will do for A+. This is more network plus. But I do want you to understand why you were seeing that in Coursera and why it didn't make sense. Because we hadn't gone over this, and neither did they.
let me see if I got this straight. So you have the network IP address up there, like that's the main network IP address.
Well, this would be an IP address I was sending information to.
Yeah, so like it would be a network in like a main network in like a building.
Yeah. So and then the first 3 would be that the network, and then this last bit would be the individual host I'm sending it to on that network.
Okay, so and then instead of /24, it goes to /26 so that it utilizes the 2 bits.
Yes.
And
which
then
breaks it down into 4 networks.
And it would then go like, so let's say like it was in C with the 128 to
191.
191. And that would be like the I don't know, like the accounting of that building, like where
yeah. So say C would be accounting, A would be marketing, B would be operations, and then D would be like HR.
All right, that all comes together. All right.
So is this kind of clear?
It is clear
Joyce.
now.
Okay, good deal, Kevin. Yes, Joyce.
So I think I don't understand why it would be /26. That's
Because,
what I'm trying to see.
So like, remember like class C was the /24, right? If we added up all of these bits, that would be /24, right? 8 plus 8 plus 8. Right? So we're taking an additional 2 bits. So instead of a /24, we're going /25/26 using those 2 bits. So we're basically telling our system that these 2 bits as they come across tell you what network it's supposed to go to.
Okay, so it's just adding 2 extra bits.
Yeah. And then the last 6 bits would be our host address. Is that clearer?
Yeah, now it makes sense.
Okay. Stephanie, you look like you have questions.
No, she had just asked, she just asked the question, but I wanted to know where the 26 come from.
Okay. Does it make sense? Okay.
Yeah.
We're taking
I'm
one step at
getting
a time. Okay, that's
Yeah.
all we're trying to do. We don't need to be experts on the CIDR subname. We just need to kind of have an idea. And we're going to do some examples, and you guys are going to work them out on your own. Did you have another question, Joyce? Or are you good? All right, Golly.
All right, so I know I'm repeating like it's the same thing, but so then, okay, so when that message come through that building to like the /24, so like let's say the /25 will be another person inside of that building, and then the /26 will be somebody else also, like another department type of
You
thing.
could do that, but we're trying to keep it simple. We're going to say all the networks are broken down into the same way. So you could do like /25 for half your network and then do 2 /26s for the other half, but we're not doing that. We're not going to confuse you guys like that. This is just a introductory view of CIDR.
Okay.
So what we're saying is like you as a network engineer designing your network could set your network up to look like this, or you could set your network up to look like this. So you could have A and B networks and have it be maybe administration and operations. Or if you wanted to break it down further, you could have HR, accounting, operations, and sales.
And
So
okay, so then lastly, when you said that the other 6 bits is for like the network, like what you say was for like
to identify the
host
individual computer on that network.
So then that means it could keep going. Could it go to like after the 2 bits? Could it go to 3 bits, like 4 bits?
I'm glad you asked that question. Let's take the 3rd bit and divide the networks up that way instead of having a /26. We will call this a /27. Yes, Emily.
I wanted to know, how did you get the numbers where it says 000110?
Oh, those are the binary bits.
The ones next to it.
What, these numbers?
Yeah.
I broke them down into even chunks. So like we have, if we didn't break it down, we had 0 to 255, right? That was the total number we could have. So if I cut this in half, what would be the halfway point? It would be 127, right? So 0 to 127, because remember 0 takes up space, all the way to, and then we would have 128 all the way up to 255, which is as high as we can go. Does that make sense?
Yeah.
And then when I went to 4, I just broke down each of these into smaller chunks.
Okay.
So I would go 0 to 68, and then, or excuse me, 0 to 63, and then 63 to 127. Because I broke this down in half. And then I would go 128 to 192, which is the halfway point between 128 and 255. Or 191, excuse me, and then 192 to 255. So I broke it down into 4 chunks rather than 2.
Okay.
So each time you go up, you double your networks and you cut your amount of hosts in half. Every step we take. So the next step we're doing, 127. So let's name our networks first. We have 3 bits now. So the first one we can do is 0, 0, 0. It helps if you do these in order because then it makes it easier to break stuff down. 0, 0, 1, 0, 1, 0, 1, 0, 0. Oh, sorry. My error. 0, 1, 1. Then we go 1, 0, 0. 1, 0, 1. 1, 1, 0. And finally 1, 1, 1. So we have 8 networks now because we've added that extra bit, right? The third bit. So first bit gave us 2. We double that, we got 4. Double that again, we get 8. /27. Our network ranges on this 0, 31, 32, 63, 64 to 95. 95. We got 96 to 127. 128 to 159. 160 to 191. 192 to 223. 224 to 255. Here we go, make sure I got all that right. All right, so that's our 8 networks and their ranges. Initially, you'll have to kind of do the math each time. Eventually, if you use this stuff enough, you'll just kind of remember the ranges. But at first, you're going to want to write them out. Like I always write out the binary in order. And then do my ranges in order. That way it makes sense to me. So go back to our original IP address. P, C, D, E, F, G, H. All right. So our original IP address, which network would this fall into? So this address up here.
F.
F. Correct. 160 to 191. Because 183 falls in between 160 and 191, right? Now, ignore this one for a minute here. If my last octet was 86, which network would it fall in? For a /27. C? Excellent. JR. If my last octet was a 215, which network would I fall in?
G as in green.
G is in green. Is this starting to make sense? Nessanet. If my last octet was 35, which network would I fall in?
B.
B. Perfect. Rahel, if this was a /26, not a 27, 26, and my last octet was 83,
B.
which one?
64 to 127.
Perfect. She jumped over to the other ranges for /26, 64 to 127. It would fall in that range right there. Is this starting to become a little bit clearer how we break down our networks into smaller chunks? We can keep going with this. We can do a /28, a /29, up to a /30. We cannot go beyond /30, even though there's 32 digits. /30 is the highest you can go, and that will give you 2 hosts. And I think we have, 2 hosts, and what is it? Let me find it here. 64 networks and 2 hosts on each network. That would be like a /30. Very rare you would ever do that. You would do that for like servers or printers or something like that. Do we want to try a couple examples on this and see if we can kind of work through it on our own?
Just give me 1 second. Don't erase this yet.
So you know when you're good, Golly.
Yeah, just okay. I'm good. Thank you.
All right. So what I'm going to do, I'm going to drop a IP address and a / notation on it. And what I want you to do is give me the ranges and which network that IP falls in. Don't type it in chat. Raise your hand when you have your answer, okay? And we're gonna, let a couple people get it before we'll call on anybody. So hopefully you have a piece of paper or a notepad out or something like that where we can work through it, okay? Let me know when you guys are ready. We ready? All right, go.
Kelly.
Mm-hmm.
Sorry, what did you want again? You wanted the ranges, you wanted the,
I wanted the ranges and which network that one would fall in. So first you have to figure out the ranges, and then you can tell me which network the, so you're gonna give me the network it falls in and the range.
okay.
Remember to raise your hand once you've gotten your answer. I see you, Rahel. All right, Melody. We're gonna give it a couple minutes or a couple moments. Let some people do the calculations.
I have a question. The most amount of networks you will get for this will be 2 to the 8th, like 126, or well, 128th, but you said you have to subtract 2, 1 for the host and,
One for the broadcast, yes.
okay,
So whenever you break a network down, each network has to have its own host address and broadcast address.
okay.
So you always have to subtract 2. So we're not worried about that right now. Just tell me the range of the network. Don't worry about the host or broadcast. We're not gonna, that's a network plus issue. I was just saying, like, you know, that's something that you'll come across. We're just trying to find the range that it falls in, that this network. So what IP range will it fall in? What network range?
Okay.
Mhm. Just want to get a couple more.
So if you were to go into class A and class B, the ranges would be a lot.
Yes.
Okay.
Which is why we're like, you can have like a slash 19 or slash 20, and it would be a few networks, and you would have like a huge amount of computers. So I'm just saying, for brevity's sake and for simplicity's sake, we're only focusing on class C, the last octet. But you are absolutely correct, Melody. All right, Nessinette's got it. Okay, Golly's got it. Give it another minute or so. All right. Nessinette, can you give me your network range, please, that this computer would fall in?
I'm not sure, but 192, 168, 15, 150.
When I say 168 to what, 15 to what? I'm just worried, just give me the last octet. What would be your range for your network? The last group.
It would be D between 96 to 177.
96, 177. Not quite, but that is a really good A good guess. So it's a 26. This is a /26. That's a really good guess. Golly, what do you have?
So confused about the question, but I think it would be between like the 192 and 255.
You are correct. So it's a /26. How many networks would you have?
4.
4 networks. Because you're using 2 bits. So your options are 00, 01, 10, and 11. Correct? Does that make sense in Ethernet? Because we're using the /26. Melody, Rahel, did you get that answer?
Yeah, I got the
Yes.
same as Gavi. Yeah.
Yes.
Okay. Let's try another one. Don't be discouraged if you don't get it absolutely correct the first time. It's one of those things that takes practice. It took me a while to get it too. And the book was not very clear on how it was to be explained. So let's lower hands here.
And after a while, can you like, I don't know if you can go back to the previous one. Like, I know, like, I understand the question, but like, can you, when you say range and which one would be the broadcast? And so just in case, if you get a different question, like, I know which one to pick, because I didn't understand before when you said you didn't want the broadcast, but you wanted the range. So I kind of just.
Okay, so I'm just worried about the range right now. We're going to ignore the broadcast and host portion for the moment. I'll show you that again in just a little bit.
Right. Yeah. Okay. Thank you.
No problem. All right, you guys ready for another one?
Yes.
We'll make this one a little bit easier here. So here you go, 192, 168, 39, 88, /25. Is that a question or you got the answer, Stephen?
Yeah, I know what it is.
Okay. We'll wait here just a minute. Okay, seen some hands go up. It's nice. Another minute or two. So it's a /25. All right. Stephen, what do you have, sir? What is your range?
I believe it's between 0 and 127, since the last 2 numbers are 88. So it's going to be A.
You would be correct, sir. Did everybody else get that same answer?
Yes.
Yes.
Yep.
Beautiful. Is it starting to make a little more sense?
Yes.
If it's not, don't be shy. That's what we're here for. We're here to learn. I wrapped my head around this for a very long time before it made sense to me.
It's been a long time and it still doesn't make a lot of sense. So there's a question I have for you, but I didn't want to, because it's very network bus related.
Mm-hmm.
But you're right on it, and I wanted to ask you a question about something. Ignore everyone if it's going to confuse you. But So when the ISP gives you say they're going to give you a /30 or a /28 or whatever they give you, right?
Mhm.
And they give you one IP address, or they don't give you any IP address, just give you the network and the slash to 32 or whatever the case might be. How the heck do you know where it starts and ends? Because it could be I don't just that's the part I never
If they give you the
understood.
/ they should also give you the host
Give you one
address to
IP.
let you know where the range starts. They should give you like the
That's the
host
part.
address,
That's
which is the beginning of the network.
It's always the beginning, right?
Yeah, the host address is always the beginning of your range.
So
And then you
somebody
can have,
screwed me one time then,
because you have the host
because
and the
I got a
broadcast.
zero. I got a 0 one time, and that it tormented me. I remember this because I was like, okay,
What
let
was
me
the
just try.
slash notation?
Shoot, I think it was /27. It was a /27.
If it was a
It
0
was
address, I mean, it was 0 to 31.
really it would have. Oh
Yeah.
crap, for real?
Yeah.
Huh. I thought he needed to give me a real address first to
Well,
start
the
the
0
range
would
off. I
be the
didn't
real
know.
address. That would be the host address for the initial range.
Yeah, I didn't
It
know
wouldn't be
to
a
do that.
routable address, but it could be a gateway range or a router range.
Okay, because everybody else before that always gave me a real address that I could use. Address that I could actually assign to a router. To assign to my gateway. And this was the one time I got something that wasn't in that range. Hey guys,
Well, because remember, 0 takes up a place, so 0 would work as the host.
Interesting. All righty. All right. Cool. That one. That one eluded me for a while, and because it was the ISP, I couldn't just ask him to teach me about why you did that. What I mean?
I got you.
Okay. All right.
So let's see here. UKA, yes, max you can go on subnets is 30, because if you go 31, because 32 would allow for 4 places, you would have one for the host, one for the broadcast, leaving you 2 computers in the middle. If you go to 31, you only have 2, so you have your host address, your broadcast address, and nothing else available. That's why. And you go to 32, you have nothing left because everything would be network. So 31 and 32 do not work because of that. All right, so let's see here. Ready? Next one. So yeah, max /30 is your highest you can go. All right. Oh, let's lower hands here real quick. So 192.168.83.145/26. All right, 2, 3, 4. You guys are getting faster. 5. All right, Bernard. We have about another 30 seconds. Stephanie, nice. Stephen. Yuki, nice. All right, Jamari, can you please tell me the range of your network?
Is it C 128 and 192?
That is a really good guess. Very close. Wait, 128 to 192, 191? Yes, you're right. Sorry, I was looking at the wrong one. Apologies, Jamari. You were absolutely correct, sir.
I was gonna say I'm super confused then if that was
No,
wrong.
I looked at the wrong thing. I apologize. No, Jamari is absolutely correct. My apologies. Excellent work. Did everybody else get the same thing? Group
Yes.
C,
Yes.
except for me, apparently. So 128 to 191. Very good. Very good. Again, sorry for that. Looked at the wrong one. All right. Hands down. Are we making more sense?
Yes.
If you're still confused by it, please don't be shy, because we want to keep working on this. Yes, you kid.
Yeah, he just said 192, I think, but does it matter or does it have to?
Wait. You said 128 to 191, didn't he?
I made 191, but on the
Yeah.
screenshot I have, it's like a 2, so I just like that. Yeah.
It's habit. If you break it down into quarters, I do that all the time. So yeah, it goes up to 191. So slight technicality, but he was absolutely in the correct range on that one.
Okay, so the math has to be like on point, right?
Yes, but again, first you do the math, and then eventually you just kind of remember the networks
Okay.
once you work with them enough. And doesn't hurt to have a cheat sheet. But again, you're not going to have to do anything like this for the A+. You will for Network Plus, but think of this as a bonus session on your way to your Network Plus.
Okay, thank you.
Yes, Craig.
All right, I'm back. All right. So, okay. I just realized something. So if I ever encounter something like that again, I'm getting technically screwed out of an extra IP address, correct? Because if the one I gave you where I got a 0, I can't use 0. I usually assign 1 to the gateway, and then the end of my range is usually what I use for broadcast. So I'm actually losing 3 addresses then.
Well, each time you break down your network, yeah, you lose 2 addresses each time you sub.
Yes, but with the one that I got for the first group, which starts at 0, because he gave me 0 as the IP address, right?
Mm-hmm.
I lose 0, I use 1, and I use the last on my range.
Correct.
So technically, I lose 3 on the beginning network versus everybody else that gets 2.
No, not necessarily. If you use 0, you should be okay. Or then no, 0 would be your host.
Yeah,
but you're not exactly. You're not. Well, you lose it when you're not using it anyway. Like originally. So
yes, of course. Yeah. Yes. I get that. So all right. I guess the question really is then. I'm not looking at any one of your screenshots right now because I just got back to my house.
Mm-hmm.
But say that I had a later range, right? Let me see. Like 192 to whatever the end range is. In this case, let's just say it ends at 255, right?
Okay.
We already know we can't use 255, but I can use 192. I can use 192 as my host or my broadcast. You see what I'm saying? I can still use it, but I can't use 0, and I can't. You know what I mean? So
I don't know about the nuance on that one, honestly.
Oh, okay.
I apologize. I don't know, that one is getting a little bit into the weeds for me.
Yeah, no, I just know because it was a real big issue for us because we needed all the IP addresses, because it was a web server, all sorts of stuff. But anyway, yeah, I remember this very, very keenly. But thank you though.
Mm-hmm. We ready for another one?
Yes, sir.
All right, let's do another one. Let's take it up a notch. 192.168.83.16/27.
You said that's 16.
Or excuse me, 164. Sorry, I need more caffeine. I've been talking all day. Talking is hard. Especially if you're an introvert. We're gonna give it another minute, but this one's yours, Bernard. So we'll give it another minute though. All right. Go. All right. What's your range, Bernard?
My range would be 160 to 191. We'll put it in network F.
You are absolutely correct, sir. Is that what everybody else got?
Yes.
Is there anybody still kind of struggling with this a little bit, not understanding where these numbers are coming from?
I'm struggling, but I figured that I wasn't here yesterday. So this is what you guys learned yesterday, right?
Well, we were doing subnet masks yesterday, which leads into this. So yeah.
Right. So I'm not even stressing too much. I just want to let you know I'm not stressing too much until I watch the video. And then I go back and do this.
Okay, we're recording this too, so you can go back and rewatch this session and see if it makes sense too.
Great. It should make more sense.
Mm-hmm. Good. Do we want to do one more, or do we feel like we're on pretty good footing with this? We can do a couple more if you want, but just want to know
pretty
how you
good.
guys.
Unless you go like up to like 28, 29, 30, then we'll have to.
I'm not gonna make you break down those networks. That gets a little rough.
Yeah, I was about to say, but with everything else, well, I'm good, but you know, I'm not.
You think you can tackle that networking one on bits and bytes now?
Yeah. I'm
So
confident.
you gotta watch the slash notation. Now remember when you saw those little slashes at the end of the IPs? Does that make sense now?
Yeah, it definitely does. I didn't really explain it the right way. I think, but
why do you think I do the workshop?
Like, I feel like they're still explaining to you like somebody that already know this thing.
Degree,
and they're just like, oh, we just reviewing it with you, and it's like, no, I don't understand what you guys are saying.
See, the first two times I taught this course with Coursera, I taught it once without it before, and then they threw Coursera in. I hadn't done Coursera yet. So, but it was A+ stuff. So I was like, yeah, I already know the A+ stuff. No big deal. And I had a student come to me and she was like, yeah, can you please help me with this networking one? I just, no matter what I do, I can't figure it out. And we're sitting there and we go through the first 2 to 3 questions, no problem. We get to the third question and I look at it and I'm like, oh, they went there. Oh, okay. We got to have a talk. So that was when I pulled the whole class in and we do the CIDR subnetting workshop like this. Does this clear a little bit of that up? Make a little bit more sense? And
yeah. Again, if you don't mind just going like I guess I want to hear it in a question way when you say like which one broadcast. Like I know which one like is the network and the host, but like before, I didn't know like the host in the back had its own submass of network. So like,
with every network, so like with every network, 0 to 255. So that's that's a /24. The very first address, the 0 is your host. Then the 255 broadcast. Okay, so the first address is your host. The next address is your broadcast. So if you break it down, say to a /25, we have the 0, 127, and the 128 to 255. So for the first network, the 0 is your host, 127, because it's the highest number, is your broadcast. And then your next network, you have 128 is your host, 255 is your broadcast. Because you need to have the ability to talk to everybody on that network at once. So every network has to have a broadcast. Every network has to have a host. So every time you cut it into smaller chunks, each one of those networks that's a smaller chunk has to have a host, has to have a broadcast. Does that make sense?
Yeah, so I guess like in terms of like nodes and like, so it's like that mean that host is the one. So between, let's say between the 0 and the 255, the like you just like everything in between, like the host is just talking to.
Everything in between can be a node. So everything in between, you would have 254 out of 200, the 0 to 255, you would have 254 possible options for host addresses or node addresses, whatever.
And then and any of those nodes can just be like any device type of, that's what it mean, like, or right?
Any of those what?
Like any of the nodes, like nodes are like, or like devices, or
yeah, the node would be like a computer, an iPad, a phone, a security camera, a doorbell, you know, anything that's connected to the network.
Okay, I think I got it.
Because anything that wants to talk on the network has to have a host address, an IP address. And this would allow them to do that by breaking up into smaller chunks. So what would be a /25, Bernard? What were you talking about?
The last little slide that you had put up, basically when you were breaking it down, that would have been a /25, right? Because it only had the 2 networks, I guess, what I'm trying to say.
Yeah, absolutely. That was a /25. So remember, our class full subnetting is /8, /16, /24. So it's 8, 8, and 8. That's class full. CIDR is classless. And that's when you start getting into these /25, /26, /27, and you're breaking it down into smaller and smaller pieces to make it a little more functional for you. Make sense? Are we ready to go knock out that lab real quick? All right.